Hi everyone, welcome to week 5. I really apologize for not being in class in person on Tuesday. I was sick with norovirus, which was pretty awful, so try not to get that if you have a choice. Um, I was especially disappointed not to be there to introduce you in person to some fundamental concepts from programming. So I'm going to go over those with you on this video, and then we'll check back in class this coming Tuesday and see how you're doing with it. So I'm looking at a set of slides that you can find on our syllabus on week 5. Just scroll down a bit to in-class activities, and we're looking at these slides here. Feel free to follow along with me. So the plan originally was to start with an administrative check-in and then talk about the problem of access. I really like the problem of access a lot. I hope you did too. I hope you enjoyed that talk. But obviously it's not so much fun for me to have a discussion by myself. So we'll move on to step 3, talking about control structures. Then we'll do a little bit of basic Python vocabulary and syntax. And then we'll walk through a Python program that you can run yourself using your own Amazon data. So let's skip that until we're together again. And just a couple words about what I'm hoping to accomplish this week. So you probably have already guessed that you're not going to emerge from this one class as an experienced programmer. It takes years, of course. But I do want you to be able to actually be able to conjure an image of what programming looks like. I think it's there's something sort of mystifying and perhaps intentionally so about what it means to code. And so I want to kind of clear away that veil of mystery a little bit and allow you to picture in your head what it looks like to code, to recognize that there are some fundamental structures that apply to all programs and programming languages, regardless of the details. And then we'll look at some simple examples of an actual programming language called Python, and walk you through them. And then, of course, point you to some additional resources that you can look at if you find that you enjoy doing this kind of work. Any kind of introduction to coding sometimes feels like drinking from a fire hose, because there's like a lot coming at you. There's obviously there's a new syntax and new orthography. There's periods and colons and commas to worry about. And then there's also like programming logic, which has its own set of patterns and a kind of rigidity that you may not be used to if you work in other modes more commonly. And so it can feel really overwhelming. We're going to keep it as digestible as possible, but you also may find that you're a little bit disappointed with what it actually looks like to do programming. You may have a picture in your head of what programming looks like that isn't entirely accurate to reality. So, of course, there's a meme for that, and let's look at this educational example. This is a lot more true to reality.
God fucking.
Getting an error, Googling the error, copying someone's ancient code from 2011 on some obscure discussion board. That's what it looks like for most people. Very few people are kind of surfing the cybernet and hacking into the FBI immediately. Well, very few people in general, probably. Anyway, So don't be disappointed if it doesn't look quite like you thought it would. But it is good to know that there are a few simple patterns that characterize every program that runs on a computer, just by virtue of the way that computers work. And sometimes they're called control structures. And it's good to know about these because they're kind of like the building blocks of computer programs. So you probably recognize these structures from the video you watched for today. These are like the three foundational control structures, the selection, iteration, and sequence. And they're depicted as flowcharts, which have their own specific visual syntax. Flowcharts are pretty common when people are trying to map out how a computer program works. And when people draw flowcharts, they use a diamond to represent a decision, a rectangle to represent a step, and a circle indicates a connection to another part of the program. So let's look at how that works. Let's start with sequence because it's the simplest. So you've probably already gathered that a program that runs sequentially just moves from step to step to step and so on until it reaches the end. A, a, an example of a situation like that might be, you know, write a line in a letter, write another line, write another line, write another line until you reach completion. Not a lot of decisions to be made in that scenario. Now, a selection is a little different. It starts with a decision. So the way that is represented here is that there's some kind of truth claim, such as 5 is greater than 4. If that's true, you proceed to a particular step. If it's false, you proceed to another step, and then you can continue on to the rest of the program. So let's think about scenarios where that might apply. Has the cake's internal temperature reached the right level? If true, take it out of the oven. If false, return it to the oven. So that would be an example of a decision that you would make and a selection following the decision. An iteration is also called a loop or a while loop. And it, like the selection, it starts with a decision. Is this claim true or false? If the claim is true, you proceed to a step and then return to that decision and keep doing that until the claim is no longer true. So, for example, the cake has not reached the right internal temperature. If true, put it back in the oven, check again until the cake has reached the right internal temperature, at which point you can proceed with the rest of the program. So we talked a little bit about why these structures are so important. They're the basic building blocks of any computer program, no matter how complicated. But they do tend to be nested inside each other and connected in lots of really creative ways. But looking for them can help you identify the foundational elements of any program you're looking at. So let's talk through what's happening in this flowchart. First of all, you might have recognized a loop here, the while loop. Remember, we do something while the claim is true, and it's something else while the claim is false. We return and keep doing it until the claim is either no longer true or no longer false. So start, proceed to a step, pump air, and then we have a decision to make. The tire is at the rated pressure. If yes, we're done. If no, pump air again. So keep repeating until we're finally at the right pressure, and then we can end. Okay, let's see if I can show you this in a little more detail. Okay, so here's another diagram. We've got a slightly more complicated loop here. So let's see what it says. We start, we turn on the oven, we wait, and we have a decision to make. Has 4 hours elapsed? If yes, we've reached the end. If no, we have another decision to make. So is the thermometer at 180 degrees? If no, we return to wait. If yes, we end. So this is an example of an if-else. So if 4 hours have elapsed or the thermometer is at 180 degrees, then we can end. But if neither of those conditions are true, then we have to continue to wait. So if this is true or if this is true, we can end. But if neither of them is true, we wait. One thing that's good to know about computer programs is that they often nest up, their elements often nest inside each other. And this is a property called modularity. So here's an example of making Thanksgiving dinner. You might make mashed potatoes, you might bake turkey, and then you might have a decision to make, is grandma here? At which point, perhaps you set the table. When people are assembling computer programs, they often get so big and so unwieldy, so complex, that it's difficult for any individual human being to hold all the elements in their head. And so rather than try to write out each individual piece of the program from scratch, they'll often pay attention to packaging it in a way as a module and using it kind of like a building block that they can attach to other parts of the program. So for example, if I'm writing a program to accomplish Thanksgiving dinner, and I know that my friend has already written a little module with instructions for baking the turkey, then I can just snap their module into my program, assuming that I know what kind of data it wants and what kind of output it'll deliver, without necessarily knowing the details of what's inside. So I don't really need to care about what's happening in here as long as I know that the outcome is reliable. And again, this process or this property is often called modularity, information hiding, or encapsulation. Perhaps we can talk in class about some of the epistemological or social effects of the fact that so much of our infrastructure is built from these modules, which are also sometimes called black boxes. What do we get when we pile black box atop black box to create the fabric of our infrastructure? But for now, we're keeping it very pragmatic. So let's go back and let me introduce you to a new kind of document. And this is where we'll be doing our Python programming. I wanted to just take the next couple minutes to explain what kind of document this is, because you might not have encountered it before. It's called a Colab notebook, and here's one that I think would be a good one to start with. This is not meant to teach you Python. This is just meant to introduce you to a Python or a Colab notebook. And you can think of a Colab notebook as sort of Google Docs for Python. And they're composed of a combination of text cells and code cells. And text cells are kind of what they sound like. You use them for usually explanatory text. You can edit them, and they use this particular syntax called Markdown, but you don't need to learn that if you don't care, because there's also a formatting menu here. So those are text cells. In addition, we have these code cells, and you'll notice that when you hover your mouse over the code cell, we see a little play button. in the top left-hand corner. And that's because you can actually run each code cell and get an output. Then you can go back to the cell and edit the contents, run the cell again, and see what happens. So let's just try that. When you get to this document, go ahead and save a copy in Drive so that you can have your own editable version. And then let's see what happens when we press play. So the code is running. You can see that the back end is getting all set up. And we have some output here. In this case, it's asking for some input. So let's say, Harry, elegant, and continue. As I mentioned, I'm going to stop this because I'm not going to complete our Mad Libs, although you should. As I mentioned, you can go in and alter the code to your heart's content just to see what happens and then run it again. You might get an error, but that's okay. Those errors can be informative too. If you get frustrated and want to start over, you can go to runtime, and then you can either interrupt execution or restart session, and that'll clear all the previous information from that session. One thing that's good to know about Colab notebooks is that as you play each cell, they sort of stack on top of each other. So that, for example, if you set a variable here, like here we're setting a variable called name, the next cell will remember it, and so on all the way down to the end of the page, as long as you run this cell. So the program won't remember it if you don't run the cell, but if you do run the cell, you can pass information from one cell to another. And that's another reason why you might want to halt and restart your session if things get too garbled from all the cells passing information to each other. You might want to just start over and see if you can take it from the top. So that's what a Colab notebook is. I hope that isn't too baffling. In the olden days, and still to some extent today, if you wanted to do any Python programming, you had to download the Python language onto your computer along with some kind of programming environment. The problem with that, just for teaching purposes, is that it can get a little hairy depending on what kind of computer you have and all that kind of detail. And so this is just a way to run Python code in the cloud. And it's really commonly used to explain little bits of code. And a nice feature is that you can always copy someone else's Python notebook and edit the elements until it does what's relevant for you. So that's our first Python notebook. Let's move on to the next one. This one is called Getting Started with Python. And I've actually already made a video for you that walks you through this notebook. You can find it in the introductory explanation on the notebook itself. So when you're ready, go ahead and walk through this notebook alongside the video and see how it goes. But for now, let's look at the third Colab notebook that we're going to work on together. And this is the one where you're going to look at your Amazon spending. So just as you did with the first notebook, go ahead and save a copy in Drive, and that'll allow you to make changes and save those changes and keep your data private. And you should, when you get started with this Colab notebook, have somewhere on your computer either your own Amazon order data or the sample data that I've provided for you. So if you don't have your own data, go ahead and download this sample data and save it somewhere on your computer because you're going to need it in a second. So I think I've already downloaded it, but it's called retailorderhistory.1.csv. Okay, so let's move on to actually running our program. So the first thing we need to do is import some Python libraries. You can think of those as kind of like browser extensions. They add functions to your program. Technically, you could accomplish all of these steps without importing these libraries, but these are a bunch of pre-built functions that other people have built for you. Remember, we talked about modularity, so this is where we're making use of someone else's section of a program, and this is a way to do it. And in our case, there are just a couple of libraries that we need to import here. There's one called Files that assists with manipulating and handling files. So we're going to import that. And we're also going to import a data analysis library called Pandas. And we'll give it a nickname because it's a little unwieldy to type it out. So we'll call it PD. So when you're ready, press play. Here it's initializing. Okay, and it's completed. Notice you don't have any output from that. So not the most exciting step, but still necessary. Okay, so let's move on to the next step and look at what's happening here. So if you look closely at this equal sign, you'll see that we're setting a variable. Remember, the single equal sign indicates setting a variable in Python. Our variable is called df, and it's the definition of this variable is whatever is the result of this function, and the function is called files upload. So let's see what happens when we press play. Okay, let's choose a file. Somewhere in my downloads. Ugh, I really need to clean that out. Yeah, proof that information studies professors are terrible practitioners of their own fields. Okay, here we are. Retail order history 1.csv. Open, and it's uploaded as retail.orderhistory.1.csv. Make sure that's what it actually is called. We had a couple instances of people uploading it multiple times and getting additional names for it. So just know that like whatever name appears here is what you want to appear in the quotation marks. So for example, if for some reason it's called retail.orderhistory.1.csv parentheses 3, then you need to alter this as well. So anyway, we have a variable called df that refers to this document. And now we need to tell our program how to handle this kind of document. And specifically, we need to tell it that this kind of document is a CSV. So we're going to use a method from Pandas called read CSV. So the read CSV is going to look inside its parentheses to see what it's supposed to read. And we've specified the name of our file here. So let's press play. And we can tell by the check mark that that's complete, although we don't know what that looks like yet. So let's do that now. We'll use the head method to print out the first 5 lines of our document. Okay, here we go. So we should have five rows. Perhaps you want to see more. You can just change the input here a little and see 8 rows instead. So we're now interacting with the CSV via Python, and this might be a good moment to just remember what we talked about last week with regard to CSVs, that computer programs expect them to be formatted in particular ways using a particular syntax. The benefit of that is that programs can then work with them programmatically, as we'll see as we proceed. So let's get a sense of like the parameters of this this spreadsheet by pressing play here. And we see that we have 59 rows and 23 columns. So that means we have 59 individual records, which are described in 23 different ways. So 23 individual columns. Good to know. Okay, now see if you can use the columns method to see how many column or to list the column headers. And so the syntax is just the same. We're calling our variable and then specifying that we want to see the columns. So press play, and there we have a list of columns in the spreadsheet. Now let's see what happens if we use the info method. So we'll specify our variable and then use that same syntax. And we don't have to put anything in the parentheses in this case. So press play. And now we have data about the specific values that are in each column. Now let's see how much we spent on Amazon in total. We're going to identify a column and then use the sum method to add up all the values in that column. And you might notice that Pandas expects a particular format to indicate that you're referring to a specific column. So first you indicate the name of the variable that contains the column, df, then brackets, quotation marks, the name of that column, and the quotation marks and brackets, and then you perform some action on it. In this case, add up the contents of that column. So let's see what happens. And we have the sum total of the spending in the total owed column. We can do the same thing to get the mean, the average spending. And now let's try getting the median spending. Let's see. So you may have anticipated already that it's a very similar syntax, 1595. And we can do even more things. We can ask about the maximum we spent, $210, and now the minimum. Let's see. Okay, now let's look at how we can sort the values in our column. And we'll use a function called sort values. And when we invoke this function, we have to tell it how we want our columns sorted and in what order. So we need to identify that we want it to sort the total owed column. By default, this column sorts things in descending order. So we're going to change that. Now, by default, it sorts things in ascending order. So we're going to change that and sort them in descending order. So let's check and see what this looks like. Okay, so now we can see our data sheet sorted by the most expensive orders in the total owed column. Very interesting. So we can also do something similar, but sorting them the other way, and see if you can think for a sec how we might do that. It's very similar, except we're going to change this, of course, to true. And press play. There we go. Now we can view our records according to least to most expensive item ordered. So that might be enough for you, in which case you should sit back and feel good about your first foray into programming. But perhaps you'd like to continue and see how to plot your Amazon data as a graph, just like we did using Excel last week. So let's see how we could do that. We're going to make a bar chart that shows how much you spent per year. But just like with Excel, we have to prep our data a little bit first. Remember, we had to move things around a little bit and change the format, and that's almost always the case when one is visualizing data. And in this case, I happen to know that the formatting of our data isn't quite right automatically for the graph that we want to make. Because remember, we want to sort by, or we want to graph by year, but the data that we have is specified by day. So we need to somehow extract that year data from this column and put it by itself in its own column. Now, in fact, I'm using the sample data, and you might be too. So if you're using the sample data, there's only 1 year included in this spreadsheet. So I'm going to use months. If you're using your own data, it might be more illuminating to use years. If you're using years, you can just keep all of the cell contents as they are. If you're using months like me, you'll have to edit just a tiny bit. But not immediately. Right now, what we're going to do is just tell the program what format to expect that date information to appear in. So we're going to specify our column and set a variable. So we're going to change the definition of this column. And then we're going to use a function called to_datetime and perform that function on this column. And then we have to explain what the current format of the data in that column is. If everyone was working with data in an identical format, we could specify that here. But because the sample data and your actual data use slightly different formats, we'll use the descriptor mixed. And that just means that our program is going to look at each individual date and decide how it's formatted before reformatting it as a date time. The drawback of that is it's a little slower, but it's not a huge program. It's not going to be a big problem. And then we'll print out our first 5 records just to make sure it worked. So let's see. Okay, so we know it worked because it didn't get upset at us, and our order date is now formatted predictably for our subsequent programming purposes. So here's the part where I'm going to switch to months, but you should feel free to use year if that's more useful for you. What we want to do is create a new column that just contains the year. So we will specify first that we're creating a new column within our data frame composed of the current contents of order date with the, in my case, month extracted. For you, it might be year. So we're using the date time method to extract the month. And then we'll print out the first 5 records just to make sure it worked. Okay, so if we scroll all the way to the right, we'll see that in fact it did work. We have our separate column with either the month or year, depending on how you did it. So it's getting a little confusing kind of adding elements to our original data frame. So let's just make a new one that contains only the year column, or in my case, the month column, and secondly, the total owed column. And that'll just make it a little simpler to get our heads around what we're doing. So we're going to create a new variable composed of these two columns from our data frame and use the copy function to copy them over to this new variable. And then we'll print out the first 5 rows. So let's see. Oops. Oh, right. I forgot that I switched to month. Let me just change the name of this variable too, so I don't get confused. Switch it here as well. Try it again. There we go. And now we've counted up the total owed per month. Very good. So it seems like we're getting very close to being able to have our plottable data, but remember what happened when we tried to do something similar in Excel. The visualization program didn't immediately understand that we wanted to add up the values for each month rather than graph each one individually, which is a very common problem, as we discussed. So we have to make the equivalent of a pivot table with our Python data. And we'll do that by making a new table called group data using a pandas method called group by, which does kind of what it sounds like. It takes this column and adds up whatever is contained in this second parameter here. So group by year, and the corresponding value should consist of the sum of the total owed for that year. I'm going to change the contents of this just a little bit. Okay, let's see what happens. All right, and that worked. So now we have the sum for each month, or you might have year. And bear in mind that you can also use the mean or median function here if that's what you're interested in. Okay, now we can finally make our graph, and we'll just use a built-in function in pandas called plot to make a bar chart, the x-axis of which is year, y is total owed, and then we'll just set the size of our chart. Otherwise, it'll be set for you automatically. A bar chart, as pandas understands it, is a vertical bar plot. So if you want to make a horizontal bar plot, you have to specify that. But we're going to stick with vertical for now. So let's see what happens. Here we go. And now we have a lovely chart in which we can see how our spending changed over the months. So here are some additional exercises you're welcome to try. One way to get some hints about how to complete these tasks is to refer to this blog post. I will say also that while Google does not work for many tasks that reasonable humans want to perform, it does work pretty well for programming questions. So there you go. That's a benefit. And of course, you probably could have done this faster in Excel, knowing what we know from last week. But keep in mind that the real benefit of having gone through all this work is that next time around, you can just perform all these steps automatically. So you don't have to construct all these individual steps. You can just run it on the new data. In fact, you could build a standalone program that performs all these steps for any user. So this is a sequential program. We didn't have any while loops or decision points, really. It's a sequential program with what I hope is a useful output. And I hope that was fun for you, or perhaps horrifying. I know it was for me to see my Amazon spending. If you enjoyed doing that, I have a few resources that I suggest. I have a little bit of a bias toward these video training courses. They used to be called lynda.com and now they're LinkedIn, which I'm not crazy about, but in any case, I think that these courses are carefully developed and quality checked and come with lots of useful exercise files and supplemental material that I think are worth paying attention to. Just note that you have to log into LinkedIn Learning using your LA County Library or City Library credentials. There's a fun book called Automate the Boring Stuff with Python that I think people have really enjoyed. And it teaches you how to do really common like file manipulation and organization tasks using Python. We also have a lot of Python books in the UCLA library, which would be very expensive if you had to try to access them elsewhere. Oh, I forgot. I'm not using the UCLA VPN, but were I could read this book, Python Projects for Beginners. And finally, UCLA often offers very useful workshops on a lot of different topics, and if you don't see the topic you like, you might just write to them and ask for it. And particularly if you're able to get a few other people together, they're often happy to offer the workshop on that topic. So I hope that was fun and useful and not too terrifying. I am really sorry not to see you this week, but I'm really looking forward to seeing you coming up this Tuesday. Do your best on the homework, see if it makes sense to you, and we'll go over it in class and walk through it together. So have a good weekend, and I'll see you soon.